Our next presenter is Shruti Raghunathan, Disarming Cancer's Escape Plan.
So think of your immune system as a well-organized army with neutrophils, a type of white blood cell, serving as frontline soldiers. So when neutrophils detect a threat, their plan of attack is to release these complex multifunctional structures called nets that are designed to trap and neutralize invaders. And this is a critical defense mechanism for protecting our body against disease. But what happens when the disease uses these nets against us? Unfortunately, that's exactly what happens in cancer, and that's what makes cancer such a difficult disease to treat. So when neutrophils detect cancer in our body, they recognize it as a threat, and they become activated and they release these nets. But what cancer does is it hijacks these nets and uses it to break through the blood vessel walls and move through the bloodstream to different parts of the body through a process called metastasis. And this can be devastating because as soon as cancer moves from its point of origin, it becomes much more difficult to treat and the chances of survival drop drastically. So this led me to ask the question, what if we could find the neutrophils that are being exploited by cancer and stop them from deploying these nets before they can be used against us? To achieve this, I developed a novel nanoparticle system that's loaded with a drug that prevents neutrophils from releasing nets. A critical challenge for this system is to make sure that we are preventing the release of nets from neutrophils that have been exploited by cancer while letting the rest of them perform as they're supposed to. So by encapsulating this drug in a nanoparticle, we prevent it from interacting with healthy neutrophils in our bloodstream. This nanoparticle is designed to find those neutrophils that have been activated by cancer and deliver the drug exclusively to this subset of neutrophils. By doing that, we keep this important immune function of neutrophils intact where it needs to be, but shut it down at the site of cancer where it's being used against us. So I tested this therapeutic approach in the context of triple-negative breast cancer to see if we could prevent it from spreading from its point of origin in the breast to other organs. The reason I picked this disease is because the survival rate for its patients dropped from 90% to 12% once the cancer has metastasized. In mouse models of triple-negative breast cancer, we found that this strategy was extremely promising. In mice that received no treatment, the cancer overwhelmingly metastasized throughout the body, and the mice eventually succumbed to this disease. But for those mice that did receive the treatment, we found no evidence of metastasis, significantly prolonging their survival time. So by disarming cancer's ability to manipulate our own immune defenses, we can find a way to prevent the spread of cancer. Thank you.